Hi, everyone. Thanks for joining today. Our goal here today is to talk about Mythos and give you a little bit of a reality check specifically around what happens in the OT space. I think what's really important that we want to look at today is we know there are issues in OT environments already, and how does Mythos and some of the AI-powered attacks essentially change that equation for asset owners in the OT space? I have with me today Tom Sego, the CEO of Blastwave, and Aaron Boyd, a penetration tester from ICS Blitz. And I will be introducing them to talk about their sections so that we can hear their perspective on the problems. I'm very interested specifically in hearing what Aaron has to say, and so we'll hear about that in just a bit. I started about 2 years ago to really see the impact that AI was going to have on the OT security space. Just like this quote from Harry Potter, everything's going to change now. It is going to change. The question is, what do you as an OT asset owner need to do to fix that or to react to it or to change your behavior? And essentially, what we're going to explore a little bit today is how this AI technology may impact the things that you are thinking about from an operational perspective on a day-to-day basis. The first thing I wanted to call out specifically is that complexity equals vulnerability. And the reason I'm kind of making this point at the start is this is where AI is so powerful in being able to find and exploit vulnerabilities. The more complex and the more interactions that exist inside code bases, for example, or even interactions of systems, results in complexity that can be exploited by AI technology. And we saw the first potential of how AI could be used to drive attacks against essentially networks with a report by Anthropic on a Claude-powered attack. And a human essentially pointed the system at a target, and it spawned numbers of agents and agentic activities to first gather data on that target. It looked for the systems that it had, known vulnerabilities, users potentially of that system went out and found who might be administrators or users of that system. It conducted, based upon that initial view, what are some vulnerabilities of the systems that we found? When you do network scans, you get back fingerprints which tell you what kind of system is, or you get login banners which help you understand what it is, or even something as little as the MAC address that it responds from can tell you maybe what vendor that is from. Then, based upon the users, it went out and harvested credentials. We conduct phishing campaigns, figure out what the users' names are, get them to respond to phishing attempts so I can steal their credentials. And essentially, what Anthropic reported for this was that AI conducted about 90% of the campaign. At the peak of attack, it was making thousands of requests, multiple per second, essentially giving first proof to the machine speed thing that we hear a lot about with attacks. And what we've now seen is this was how AI can conduct attacks. Now there's a more potentially more dangerous use case, which is really what Mythos. And Mythos is a new model that was introduced by Anthropic, which is really targeted around finding security vulnerabilities in code that is designed to be used by people who are maintaining this code to help them create more secure projects or more products. So Anthropic, rather than release this publicly, they decided that this was a tool that was extremely valuable. They wanted to control its introduction to the wild, essentially. So they created something called Project Glasswing. And what Project Glasswing did was take a lot of the cybersecurity vendors who are responsible for protecting networks, people like Microsoft and Palo Alto and CrowdStrike. So these companies that are today the gatekeepers into protecting networks, say whether those are enterprise or OT or IT, and providing a little bit of protection for them to get a first pass at this so they can basically protect and solve these vulnerabilities by themselves. Just as of May, which is I think about a month after that, they've found 1,500 different findings to open source projects. Only 97 of which were patched, which is about a 6% remediation rate. And that's less than 1% of the total discovery findings. So there are thousands of potentially vulnerabilities just in the open source that were found. We're not going to say what happened in Microsoft and other companies, although you can see the first Patch Tuesday after Microsoft was given access to Anthropic and Mythos and really ran it and started applying it to their system. Patch Tuesday was pretty darn large, and the problem that you see here is these kind of get cascaded. So it's not just once you fix one bug, then you're done. It's you keep finding them and finding them, and as again, one of the interesting things about Mythos specifically is it has the ability to daisy chain within code. So it's not just a bug that causes a memory leak, but it's the memory leak which causes this, which opens opportunities this. And they actually had one of the exploits that was 30 vulnerabilities deep, essentially. So a chain of 30 events. So this is where AI is really good, again, at chaining these things together to find something that a human engineer or a human quality assurance tester may not find. And Anthropic recognized that this was dangerous, and they presented it as such to the world. However, last Friday, Mythos was classified as an export control weapon by the U.S. government, and they had to pull it from the market. I won't go into the he said, she said in this, but essentially what it shows is that this is a very powerful tool, and it brings out to you as a user, how should I react, and what are the dangers that Mythos brings to my network? And we know specifically that OT patch environment is already very challenging. It's when you patch something in an OT network, you don't want to do that immediately because it causes downtime, and OT is all about uptime. How do you deal with this? And what Mythos really does is it says the urgency to patch software that can be accessed from the internet becomes very pressing. But you can't just find the bugs. You've got to fix them and validate them. And in a OT environment, there's a lot of safety concerns. You have to make sure that fixing this thing here doesn't break something else. And you have to basically understand all of the chain of events. And the biggest problem for IT and OT networks is that what I call the Mythos chain of pain, where you find this vulnerability. And if it's in a protocol or in an open source piece of software, you may have a scenario where 4 different vendors in your environment use that software, and I now have to fix all of them. But I can't do it unless vendor A fixes his, and B, and C, and D, and then I can patch it so that they all communicate in a secure fashion. And it may even be that one of these vendors has 4 or 5 different products deployed in your network, and they all have to be what I call flash upgraded. So you can't upgrade one part and then upgrade the second and third. They have to be upgraded at the same time because they're all using the same protocol to communicate. That flash upgrade in OT is extremely painful because it requires you to take down your entire infrastructure. So this kind of sets the tone for that. And what I want to do now is bring on Aaron Boyd to talk about how he sees the environment here. And when we look at what even Gimli said in Lord of the Rings, where the best kind of security is when the dwarf doors are invisible and closed, so your own masters can't even find them and their secrets are forgotten. So what are the ways that we can take an OT network and make it look like this, where you can't find it? So let me turn this over to Aaron, and we'll start from there. So what we're really trying to do is find a way to help these OT networks not have to deal with vulnerabilities and make themselves invisible. What we're going to do now is have Aaron talk about how he looks at networks, and when he does testing for OT companies, how does he look at that? How are the problems? And most importantly, what are the risk factors that kind of drive the decisions that the OT operators make? So what I'm going to do is turn that over to Aaron. He's going to talk about the reality of OT networks and the vulnerability crisis. So Aaron?
Awesome. Great. Thanks so much, Cam. Great to meet y'all. And thanks again to the Blastwave team for inviting me to the conversation. My name is Aaron Boyd. I've been breaking into and securing industrial control systems for most of my career. And this is definitely a topic that deserves all the attention it's been getting. So before going into the details, I think it's important to take a step back and we need to remind ourselves that, OT networks were built for availability, not security. So really, we need to remember that everything was historically engineered with the primary focus being on availability, determinism, and safety rather than cybersecurity. So a lot of the systems today, being that they were designed decades ago, long before we had business requirements like persistent connectivity, remote access, and cyber adversaries really were not considered realistic threats. So when we start talking about things like programmable logic controllers, PLCs, distributed control systems, and safety instrumentation systems, they're often deployed in physically isolated environments with the assumption that only trusted engineers would ever interface with those types of systems. So as a result of that, authentication, encryption, and logging were either minimal or just entirely absent by design. Over time, now business requirements are starting to surface, such as centralized monitoring, remote maintenance, vendor access, and as much as I hate the term, I have to use it because it's been embraced as an industry term, is IT/OT convergence. It's now introducing connectivity into these environments without fundamentally re-architecting their security posture. So unfortunately, due to this, as a result, this has created a mismatch between how these OT systems were designed to operate and the threat landscape that they are now exposed to. So, for example, the legacy operating systems, proprietary protocols, and embedded devices often really can't support those modern endpoint security tools. You can't install EDRs on PLCs or SIS systems. Can't really encrypt traffic as it needs to get from point A to point B as quick as possible. And you can't have a delay in those communications with something that needs to decrypt it first. And of course, frequent patching has never really been a thing in our world because we can't risk downtime or potential safety incidents. So consequently, due to all this, a lot of organizations are operating with known vulnerabilities that persist for years. And the important foundational that I think is really critical to understand is that OT insecurity is not necessarily the result of negligence. It's just been architectural inheritance. And I do firmly believe that any realistic discussion of modern threats really needs to start by acknowledging that most industrial environments were never built to withstand the adversaries operating at internet scale, speed, and sophistication like they're starting to today due to AI. And the important takeaway with that comment I want to share is that AI really does not create the weakness, it just really exposes and accelerates it. So if we could go to the next slide. So now just talking a little bit more about the industrialization of vulnerability discovery. So vulnerability discovery has really evolved from what used to be a largely manual, expert-driven activity into a really more increasingly industrialized process supported by the automation and tooling and now AI-assisted analysis. So traditionally, finding flaws in industrial control systems, software, and protocols really required that deep protocol knowledge, reverse engineering skills, and really a significant time investment just getting your hands on those kinds of things. But today, there's automatic static analysis tools, fuzzers, and vulnerability scanners that can analyze really large code bases and binaries far more quicker than any human really ever could alone. And these AI assisted systems are further accelerating that by helping prioritize specific areas in the code, identifying anomalous patterns, and correlating findings across multiple software versions or vendors. I think it's really important to frame this accurately in that AI really does not magically or autonomously discover high impact 0 days vulnerabilities at will like some others might boast. Instead, it just really amplifies the existing techniques by reducing the amount of time and effort required to analyze these complex software stacks. So specifically talking in OT where vendors often reuse common libraries, operating systems, and protocol implementations across product lines. And this acceleration has compounding effects. So we know DCS vendors specific products can run in more than one vertical. So it's no longer one product tied to one vertical, where now things try to be more agnostic so they have bigger market share. So, for example, a single flaw in a widely deployed component can ripple across multiple industries simultaneously. And for defenders, for us, that really means that vulnerabilities are identified and shared faster than ever before, which essentially results in shrinking the window between discovery and exploitation. And the industrialization of vulnerability discovery does not always guarantee exploitation, but it does mean that previously known methods being obscurity and time are no longer really reliable defense buffers. So what I've found is helpful that I always advise my clients and my team during the day job is that we need to assume that weaknesses, once introduced, will eventually be found, and it's often sooner than we realize.
Yep.
So this is an interesting point. We're calling it the complexity tax in those layered software stacks. So we know that, or we know now based on what we see boots on the ground, is that a lot of these OT environments carry a significant complexity tax resulting from, decades of incremental evolution. So as mentioned, these systems rarely undergo full redesigns. So instead, they just accumulate layers of functionality over time. Typical OT stack might include real-time operating systems, embedded Linux distributions, proprietary application logic, open source libraries, middleware, protocol converters, remote management services, you name it. So each additional layer that you're introducing also introduces dependencies and configuration requirements and potential failure modes. So from a security perspective, complexity based on what I do as a pen tester really can translate into an expanded attack surface because vulnerabilities may exist not only in that core control logic, but also in the ancillary services that runs on it, such as web interfaces, file transfer mechanisms, logging components, or those third-party libraries included for convenience, because a lot of these things are enabled by default. You actually have to go in and turn them off if you don't use them. A lot of people don't even know they're on there by default until people like me show up and point it out. So in many cases, a lot of the asset owners, again, are not fully aware of what software components are running on their devices, let alone how frequently those components are updated or supported, if at all. So that kind of lack of transparency really makes risk assessment and remediation really difficult. We hear the term, you can't protect what you don't know, you can't defend what you can't see. But when you start talking complexity, it also hinders defenders operationally because now testing patches really becomes harder. Change management slows down if you have it at all, and the likelihood of unintended consequences increases. So for attackers that don't have to play by the same rules defenders do, complexity is an advantage for them because now the more moving parts a system has, the more opportunities exist to find those misconfigurations, exploit paths, or overlooked weaknesses. And really understanding this asymmetry is really key to appreciating why OT environments remain vulnerable despite all the significant investments in security tooling and monitoring.
Do you think that, just a quick question, do you think that's because of the kind of obscurity of OT that this problem is worse for OT than IT?
It's hard to say. There's definitely a lot of outside the box creative thinking where I really never felt obscurity really provided much real security. It just slowed attackers down just due to the limited documentation and the tooling and the expertise. But now, with all the AI tools available at their disposal, now they can just absorb it into the cost of understanding. And, as defenders, when you do a typical audit, it's like, okay, do you have any remote access? A lot of site operators and corporate personnel might be say no because your policies don't allow it, but you actually know that you don't have remote access to your environment if you're not physically there and you're not physically validating. I'm a big believer in the trust but verify approach. You'd be surprised how many reports I deliver and they're like, we had no idea this was possible. And it's like, well, that's why you should trust and verify.
Yep. All right. Next slide for you.
Cool, appreciate that. So now specifically talking AI, because that's the buzzword, that's what we're all here to talk mostly about. So in terms of OT, AI's most significant impact OT is not really the creation of entirely new classes of attacks, but again, just the acceleration and scaling of existing ones. So tasks, again, that once required manual skilled analysis, such as reconnaissance, vulnerability triage, and target prioritization, now it can be performed more quickly and consistently because it learns over time as it scans the internet and does everything, which in turn increases the speed at which attackers can adapt to defensive measures and identify new opportunities. Going into an example, an AI-enabled tooling can rapidly analyze configuration files, network diagrams, or firmware images to highlight likely weaknesses. And it can really also help correlate information across multiple compromised environments, allowing attackers to reuse successful techniques more efficiently. And then from a defender's perspective, this really creates, that time asymmetry problem, like I was mentioning before. While attackers can experiment and iterate rapidly, we have to carefully test changes to avoid those disrupting the critical operations. And AI just really amplifies this imbalance by reducing the attacker's cost of failure because they don't have SLAs, they don't have market share, they don't have to worry about public image of the customer environment if a site goes down or a plant goes down. And I can't say this one enough, as AI does not eliminate the need for human expertise, but it lowers the barrier to entry and really increases the scale at which attacks can be conducted. Pen testers, we used to call them script kiddies. So now with AI, I mean, you name the word of the week, it's always changing. So I think that OT security strategies in general really should start to assume that these malicious actors, these adversaries, are only going to continue operating faster and more persistently than they ever have before.
Yeah, there was a report by the UK National Computer Security Center which showed how the impact of AI would basically help the nation states and the experienced hackers a little bit, but it would help the guys in the basement a lot because they could now, you said, just ask AI, tell me what to do here, and they could have it. So that
Mm-hmm.
lowered barrier, I think, is really important for water authorities and these low staff type environments where you don't have a whole team supporting you and you're not a company with lots of resources. So having something that helps provide you that shield is really important.
Yeah, there's a term that it helps democratize the attack methods to people who are kind of lower down the sophistication chain.
Yep. All right. Now, next slide for you.
Everybody's favorite OT patching and the reality of it. So, as we've all known for a long time, and those that may not, patching and OT fundamentally different than IT because those assets are operating continuously. They cannot be easily taken offline without potentially impacting the safety, the production, or even regulatory compliance. That's one that often goes over unlooked. So even if patches are available, having to conduct that extensive testing to ensure that the updates do not interfere with the real-time performance of the assets or the deterministic behavior, or even violate any maintenance or warranty agreements you may have with your OEMs or vendors that actually helped you build the system or support the system. And in some cases, patches may not even be available at all just because the vendors no longer support those legacy platforms or they've just exited the market entirely. One of my hot takes in patching in general is I rarely think patches fix a problem. Usually patches just patch a specific exploit from working anymore, but the vulnerability is still there, which I've proven time and time again in the past. So unfortunately, until there's a change of approach with managing vulnerabilities and vulnerability management in OT in general, that problem's going to just continue to be there. So as a result, these vulnerabilities often remain unaddressed for extended periods, sometimes measured in years rather than months. And there's been a number of industry studies that really cite how average remediation timelines are well over 200 days in enterprise environments. So OT timelines again are even longer due to those operational constraints, which in turn this really creates a persistent exposure window that attackers can exploit at their leisure if it's ever exposed or if you have flat networks or whatnot, which I'll hone in more on later, I'm sure. So in this case, I really think the challenge is not so much a lack of awareness, but just really a lack of viable options. And when it comes to that, understanding the constraint is essential when you're evaluating, your security strategies and any approach that assumes rapid, comprehensive patching in OT environments is just not realistic.
Yes, Tom sometimes calls them never day patches because they're never going to be
day.
fixed.
Yeah, I like that. Never day. We
Yeah.
know Windows 7, Windows XP, we can throw shade all day long at those.
Exactly.
So, yep. So talking about time asymmetry, between attackers and defenders. So I think one of the defining characteristics of the modern cyber risk and OT is that actual asymmetry that I've mentioned a few times. So, attackers, they can move quickly, acting as soon as a vulnerability is discovered or a misconfiguration is identified. The time from identification to exploitation being much smaller nowadays. So defenders, by contrast, really need to follow deliberate processes that include risk assessment, testing, change control, and deployment. So being that each step is necessary to maintain, the safe and reliable operations of your assets, but collectively it slows down response times just because of those processes. So that mismatch really creates a structural disadvantage for defenders, particularly when combined with the increased automation on the attacker side at scale. So these AI assisted tools are really further compressing the attacker's timelines, which now further enables their rapid reconnaissance and repeated attempts at exploitation. And we know defenders cannot simply move faster without increasing the risk of outages or potential safety incidents. So being that asymmetry means that our prevention strategies of the past, being based solely on rapid detection and response, are really increasingly strained in the OT context. And the fundamental thing you can do to address that is just reducing exposure and limiting the potential consequences of compromise, which really become critical compensating controls, which we'll definitely be going in a little bit more later on.
Yeah, I want to poke on that a little bit to make sure people understand kind of this point Aaron made about structural disadvantage. In the OT space, when you talk about automating responses, the asset owners typically start to get a very, deer in the headlights look in their eyes because that's petrifying because of the second order consequences where when I do this, now a safety problem is. And so what we see is in IT where you can automatically just quarantine a system or take it offline or turn it off, you can't do that in OT. So some of the techniques that defensive AI are relying on do not apply to this environment because you can't do that without knowing the consequences of everything that you're doing. So that what Aaron just said about risk reduction and understanding how to prevent that is really important because you don't have the same AI advantages on the defense as you may have in IT.
Nope, exactly. So after hearing me ramble for a little while on a few different things, I think the key takeaway that I hope you all take away from this, listening in live and also viewing the recording after, is that examining OT vulnerabilities is that most of the risk is really structural rather than tactical. Breaches typically don't occur because an attacker is exceptionally sophisticated. It's because environments are complex, they're exposed, and they're really difficult to change. AI just really intensifies these conditions by accelerating the discovery and exploitation processes, but it's also important to remember that it does not fundamentally alter the underlying weakness. Effective OT security really needs to focus on architectural decisions, reducing unnecessary services, limiting the exposure, enforcing segmentation, and designing systems that assume compromise rather than perfection. It's not a matter of if, but when, is another common adage I do like to use. And while tools and algorithms might be able to help, they cannot compensate for the insecure foundations. So by understanding how vulnerabilities arise and why they continue to persist in OT environments, you really can make more informed decisions about where to invest limited resources. And structural resilience rather than reactive remediation alone, I think really is the most realistic path forward in a world where these attackers are only going to continue getting smarter, continue getting faster, and operating at machine speed with a low cost of compute. That's just going to continue to grow over time.
Yeah, and kind of to reinforce some of the points Aaron made here, I'll invite people to look at Blastwave, something called the Hackopedia, where he took a look at 23 of the kind of most well-known OT attacks. And the scary thing about all of those attacks is There were very few of them, in the order of one to two of that 23, that were sophisticated zero-day exploits. Most of them were passwords that were available or default, or a system that was left on the internet with a CVE, or it was left on the internet with a default password. So what we want to pull out of this is that there is already a significant problem, and Aaron's highlighting the fact that he doesn't even need AI to do what he does today because of the issues they're already seeing out there. AI might make this worse or make it happen faster. So the when, not if, is a very important. So absolutely, thank you very much for that, Aaron. We'll come back for during the Q&A section, but the point we really want you to understand is OT already has some structural challenges, and what to quote Marco Ramius, Sean Connery, essentially from Hunt for Red October, with the nuclear powered submarine. Essentially, what Tom's going to talk a little bit now about is essentially the sound of silence. All of those vulnerabilities and issues we talked about. What happens if the attackers can't see you, can't hear you, can't find you? So I'm going to turn it over to you, Tom, and you just tell me when you're ready to advance slides as well.
Thanks, Cam. Yeah, so thank you, Aaron, by the way, for walking through those points and reinforcing the fact that the challenge facing OT is not a shortage of security tools. It's a structural problem, and also that complexity continues to increase. This is a one-way street. Patching cycles are going to continue to lengthen, and critical systems are going to remain connected, and they're going to be more and more connected. The world's getting more connected, not less connected, which increases digital risk. So now that AI is accelerating the attack side of that equation, the question is no longer can we patch fast enough? It's what happens when we can't. And so I think the thing that is really stunning about this chart here is that when ChatGPT was launched, the average time between a vulnerability discovered and a exploit created was around 10 months if you squint your eyes. Today, that's down to 9 hours. So that means one of the fundamental things that people assumed and didn't even realize they were assuming was that they had time to react. And so reaction was a viable approach. And I think what we're trying to say today is reaction is not going to work. You really need to be proactive, and you need to hire somebody who's going to do a cyber assessment. You need to figure out where your structural weaknesses are and then come up with a robust plan that gives you the biggest bang for the buck. And I'm not selling our product in that statement. I will be a little bit later. But that's just, I think, a kind of very logical executive level, board level approach to addressing these issues. So next slide, please.
There you
Okay,
go.
thank you. So I think one thing that we have already said is that the battle has moved from vulnerability to discovery. And what's interesting about this is it's almost like fish discover water last because we've just been exposed and obsessed about each one of these CVEs. We've spent billions of dollars assessing environments, prioritizing these vulnerabilities, trying to triage them with humans. And we've forgotten that if the vulnerabilities start becoming more and more prolific and they're harder and harder to patch, that there is another way that we should be considered to address this situation because the AI, like I said, or these 3 points, AI has automated the reconnaissance. It's made it much, much faster. It's made perfect phishing emails. The level of customization, you no longer see the broken English that you used to see in phishing emails 4 years ago. Now it's very convincing and it's socially engineering at scale. And then also there's the ability to mutate malware so that a lot of these signature-based defenses don't work. Now in OT, you really don't have a lot of these kinds of EDR capabilities. You can't run agents. So that doesn't even come into play. But this is a big issue in the IT side of the house. Next slide. And this is just a, you know, there's the theory that we've talked about, and there's the evidence. And the 0-day clock chart showing how time to exploit has dramatically gone down to 9 hours from 10 months. That's proof. That's data. That's evidence. Here's another piece of evidence that OT is increasingly becoming in the crosshairs because it's so much easier to attack, and the consequences are much more severe. Ransomware in particular is up almost double year over year, according to the ninth annual Dragos report. If you haven't read it, I encourage you to read this report. Dragos does an outstanding job in researching this and putting this together. And I'm not paid by Dragos. I just really love this report. So in that report, I think one of the big issues is if you think about the average cost of a breach in an IT environment, IBM comes out with this report every year, and I think last year it was around $4.4 million for an IT breach. Now compare that to what happened to Jaguar Land Rover last year. In September, they did not make a single vehicle. The cost of that cyber attack against an OT environment was $2.5 billion, not 4.4 million. That's almost three orders of magnitude different. If you look at the NotPetya attack that impacted OT, 76 ports around the world. Cam just produced some material about that a few weeks ago. The cost was estimated for that to be 10 billion. So again, the consequences are much more severe, and frankly, the targets are easier to attack. You combine those two things together, and you're going to be able to have a lot more impactful either ransomware or a lot more impactful kinetic, or not kinetic, but cyber warfare in lieu of kinetic warfare. Next slide. So the issue here is that defensive AI is not going to save you. And there's this idea that the deployment of fast responding AI systems is going to be able to make up this gap. But the evidence, again, shows that while the time from vulnerability to exploit has dropped from 10 months to 9 hours, the time for response in terms of patching hasn't changed at all. It's still around 60 days on average. So I think the focus of our approach is we advise clients to focus more on a zero trust architecture and framework as opposed to trying to play this game of whack-a-mole and try to play this game of whack-a-mole faster. Next slide. And so the other approach is to think back, take a first principles standpoint in terms of how you look at this problem. And in second grade, you learned that if x equals 0, 2x is also going to equal 0. And if AI is amplifying it 100 times, 100-fold, 100x is still going to be 0. So if you can shut down the attack vectors, so for example, network cloaking where you can't see anything, it doesn't matter if you've automated your reconnaissance and scanning tools to where they can scan and perform reconnaissance 100 times better or 100 times faster. If they can't see anything, the answer is still 0. The same thing around microsegmentation. If you can reduce that blast radius, and we have a tool that actually can do that around a specific device, you can reduce the impact of all forms of east-west attacks, and that includes supply chain attacks. And then multi-factor passwordless MFA. So passwordless MFA is very important because 80 to 90% of the attacks that are perpetrated are usually some flavor of stolen credentials or credential harvesting. And so again, don't try to outsmart the AI. Our message is remove the target.
So again, just to emphasize what I mentioned before in the Hackopedia, where we look at those 23 incidents, if these three things had been employed in the networks that were basically attacked during the Hackopedia attacks, none of the attacks would have succeeded. They weren't passwords to steal. They could not have laterally moved between devices, and they could not have found the network. So this really does, in the environment where AI is looking for the vulnerabilities and trying to exploit them, these three uh, defenses essentially are like putting a lock on a biometric door that you have to physically turn the key. So the way to defeat AI is to have a human in the loop and force these things to happen. And this is what we're trying to do with that. And I think now Tom's going to talk a little bit about how BlastWave does this.
Yeah, so for those of you who wanted to attend this webinar and get the theory, the context frameworks, and some thinking around how to protect this and how to address the situation, you are free to leave, because now I'm going to get into the commercial part. And unsurprisingly, we have a combined integrated solution that does all four of these things in one product. You can deploy it 20 times faster than a firewall. It's about one-fourth the cost and half the administrative lift. If you multiply those numbers together, it means it's 160 times better than an industrial firewall solution. And the components, again, are network cloaking, microsegmentation, passwordless MFA, and we also have built-in secure mode access that has session recording and replaces TeamViewer and VNC. Next slide. And one of the things that we are so proud of is all of this is not marketing fluff. And there's a ton of marketing fluff out there. And it's, in fact, it's so overwhelming that a lot of security professionals are jaded to the point where they just don't believe anything. But these are facts, and we are proud of our team's ability to deliver these numbers. First of all, we've been deployed in 5,000 locations, 21 countries, over half a billion device hours without a single successful breach against us. And that includes NSA red teams, Army purple teams, and it even includes some very outstanding pen testers, one of which is on this webinar, who gave us that quote when he reached out to us. I don't know, Aaron, if you wanted to talk a little bit about your experience or not, but it
Yeah,
was
yeah,
quite,
no.
yeah.
I wasn't expecting to see the quote. I'm glad you did. So now I don't have to say it later. But yeah, that's essentially how I was introduced to BlastWave. So I have a customer that I do annual pen test for as part of their program. And then they wanted to do a before and after style pen test. So before style, the usual wreak havoc, give them a report, here's how to fix everything. And then when I came back to do it again a few months later, I genuinely have never banged my head on a desk as hard as I did. Um, Figuring out what did you do, what did you change, and then when they said they implemented BlastWave, I've never seen anything like it before. Again, I'm not being incentivized or paid to say these things. I know it's recorded. I'm happy to go on record saying it, and I just had to reach out to BlastWave to figure out what they're doing, how they're doing it, how it works, because I had no idea what I was looking at on the network. I couldn't reach anything to actually compromise it. I would have had to chain at least 11 things together. And remember, like I was saying, adversaries are going to focus on those low hanging fruits. They're going to move on if it's going to be that complex. So definitely kudos to the team for having all these things not only easy to implement and support, but also being integrated in one thing. So you don't have to go out and buy 3 to 4 different things to do different things, increasing your operational overhead.
And Aaron said, thank you for that. And Aaron said something really important, which is, we are not unhackable. Okay. BlastWave is not unhackable. I don't know anything that is unhackable, but we've made ourselves and our customers so much more difficult to attack. Adversaries just move on to a softer target, move on to the whatever the Jaguar Land Rover equivalent is. All right, you go ahead. So in terms of just a little bit more granular now, in terms of where we sit, just this is a network diagram that shows you that we sit upstream of industrial switches. We can impose layer 2 isolation downstream of those switches as long as they're a managed switch. Um, this one device, this one software appliance can be deployed on a VM. It can be deployed on very cheap commodity off the shelf x86 hardware. It can be deployed in containers, Kubernetes clusters, and it allows all four of those things to happen at once. It delivers MFA, passwordless MFA, to devices that can't even run agents. So, I mean, imagine being able to have passwordless MFA across your PLCs, HMIs, RTUs, SCADA systems, DCSs, safety instrumented systems, SIS, all of that. You get passwordless MFA across that, which dramatically lowers your risk. We deliver secure remote access, again, with built-in, very rapid remote desktop. We are over 2.2 times faster performance than anybody else in the industry, just in terms of remote access. So that's a little bit about what we do and where we sit. I think the last slide, Cam, is yeah. So this just kind of addresses the 360-degree solution. And again, this looks very first principles like, because it is. And the top is really protecting against north-south attacks, and cloaking does the heavy lifting of preventing visibility to unauthenticated people or devices. And then what ensures that visibility or lack of visibility is cryptographic authentication, which is passwordless MFA. So there's no password to steal. It's very difficult to approach to compromise that, so you don't get visibility. And then we deliver this software-defined segmentation, which, firewalls, it takes a long time to set up a firewall solution with access controls and VLANs. And if anything changes, good luck to you. And then finally, even though secure remote access is not really a security tool, it's a convenience tool. If you don't make the convenience tool secure, it's going to create additional risk for you. And so we do all four of those things in one package at a very low price, and it's easy to deploy. So Cam, commercial is over. We can get back to some more technical Q&A.
And just to emphasize a little piece that Tom talked about just now, and Aaron mentioned before, we hear we don't have remote access, so we have an air gap, or we've got one-way data diodes. Well, I can tell you, I used to do security evaluations for the Air Force very early in my career, and I can't even tell you how many times there was someone put an extra NIC card or a extra connection in the back of that computer, and you may not have thought there was another back door, but guess what? There was. So if, as Tom hit it right there, it's the convenience factor. If you make security high friction, people will find a way around it. So all of these things are also, there's a human factor to every one of them, that if you make it very hard, people are going to find a way to get around it.
And one last thing about me that I didn't share with you is I spent my first decade of my career in manufacturing. I'm a chemical engineer. I was making medicine for Eli Lilly. I was at Caterpillar. So I was wearing a hard hat, steel toe shoes, and had channel locks in my back pocket. So I understood the manufacturing side. And then my second decade was at Apple. And so this idea of bringing Apple's ease of use to cybersecurity was the entire thesis and foundation of the company, because I think making things simple and easy to use helped also make things more secure.
I used to say, Tom, that I was in the Air Force. I worked at the NSA and Air Force Information Warfare Center. My comment was always, I flew a keyboard. So that was my hacking job, was that flying a keyboard in the Air Force. So I can feel that. All right, so we do have one question that's on the Q&A, which I'll pose out, which I think I understand the question. Essentially from Peter, it says, how can we unify all these things into a single dashboard? And that's actually a really good question. It's a very hard answer in many cases, although today things are getting a little easier. I'll let Aaron maybe go first, because you've seen how the people you're dealing with try and do this. So how do the OT customers try and look at this today, that when you go out into these sites, what are they doing to try and answer that problem?
Yeah, and it's a hard one to answer because there's certain products that do things better than others, from visibility and protocol dissection, things like that. But then when you start talking the other things that are so deep in the network, it's not cost effective to put an appliance there. I will say there are solutions out there that tend to be more vendor agnostic, that are able to be receiving logs It might take some manual overhead to build the queries and the dashboards and parse the data the way that you want, but it's hard to answer without knowing the context on exactly what are the things that you're looking to display on that dashboard and what are the objectives you're looking to solve.
Yeah, I'll give you a contrarian answer a little bit to this because I have been using a lot Claude Cowork, and for those that have not, for those that don't believe in AI and don't believe in agentic and don't believe that things can be automated, I encourage you to spend an hour with Claude's Cowork product specifically because what it can do is you can say, here are the things I want you to go out, and it will query 15 different things, put together a single dashboard and tell you all of the things that it sees that are bad and that can be fixed. So the thing that attackers have at their beck and call now is the ability to do all of this mass searching, this mass mining of data, and then they get back a single dashboard, which not only shows them all of your vulnerabilities and all of your systems and all of the people, but it allows them to see all of their attack information in one dashboard. So if you as a defender don't have the ability to see some of that stuff in a dashboard, you are already behind your attackers because the tools they're using have that stuff built in already.
One other thing I would add to that, Cam, and this is we're going off the rails a little bit, just talking about AI's capabilities, but I would argue that AI is a better analyst and a better analytical tool than any human is today. Now, it can't replace humans. You still need both because the human has to both direct the AI agent to connect it to the right sources of data as well as sanity check things afterwards, because otherwise it can become a hot mess and create a lot of problems. So you can't just rely on AI without human intervention and human orchestration. But AI can analyze millions of lines of code way better than the top engineer could. AI can analyze your CRM and do rich analysis on your CRM and discover trends and things that no human would ever discover. So this is one of the things why this is such a wake up call for us, and hopefully it's also a wake up call for you.
So again, the thesis on this is that things are getting easy. So I did have a couple questions that I wanted to pose to the panel. Specifically, Aaron, you hinted at this a little bit before about kind of security by obscurity, which you don't think is actually there anymore because of AI. You know, how do you think that the asset owners have to kind of respond to this, knowing in terms of risk? And I'll put this question up, but I specifically want to jump to this one a bit. Everything that we've talked about today is a risk management issue. At the end of the day, it doesn't matter anything what I say. We have vulnerabilities and bad. It all comes down to risk. So how do you advise clients, or kind of what do you tell them around managing that risk in terms of their OT network? Because that's really the fundamental issue that this entire webinar talks about.
Yeah, I think the question that folks should be asking themselves and internally within their organization is how can you reduce exposure when you can't reduce the patch timeline? So I think by taking those concepts like network cloaking, as I saw firsthand trying to break in to the customer that I've been doing for many times over the course of a few years, and one thing kept me out. So by making those systems non-discoverable in the first place and unreachable to unauthorized users, you really reduce the probability of being targeted during these vulnerability windows.
Yeah. Any comment on that, Tom, from what you've seen? I mean, you obviously talked to lots of customers in this space as well. When you talk about cloaking to them, what is their response and how do they typically behave to that?
Honestly, no, most of the time they have no idea what it is. They're like, "What is this? How does this work? How is this different than a firewall?" And then, we spend 15 minutes usually talking about the 8 specific deficiencies that firewalls have that a network cloaking solution does not have. And maybe that's another topic for another webinar.
Yeah. And for those that, I'll just give a quick analogy for you again, since I've had some good pop culture references in here. I'll go for a Star Trek one. It's the difference between the Enterprise having shields, which are what firewalls have, and the Klingons having a cloaking device where you can't see them. So you can't attack them if you don't know they're there, whereas you can hit the enterprise time and time again, and eventually that shield's going to go down and you're going to find a hole in it. So that's really what network cloaking is about. I don't see any more questions. So I want to close out by basically there is an ebook which talks about in a little more detail some of the AI risks. We've done several bits of AI research around even like what are the dangers of using AI to map your network out or to do looks. So there's a lot of content on our site about some of the risks of AI. I mentioned the Hackopedia. So for those that attended this or registered for the webinar, we will send out a link to this ebook as well as a replay to the webinar. We invite you, if you have any questions, to reach out because one of the things, I think I'll just kind of close this out. We as BlastWave can't protect your network. You have to do that. And what we want to do is invite you to join our movement. And we want to prevent industrial cyber attacks. If it's with us, that's fine. If it's with someone else, that's good too, which is why we're providing education. But the goal is to protect that critical infrastructure and prevent these cyber attacks because they can now affect everything that we do on a daily basis. So with that, I will
Yeah,
close
and
out the
let me
webinar. And go ahead,
well,
Tom.
let me interrupt you before you close it out and just say that this, when we say join the movement, what we're really talking about here is a very important mission that we at the company share, which is this element of protecting our modern day way of life. And this is not just something that Blastwave's doing. This is something that many people, many consultants, many pen testers, many vendors, SANS Institute, there are so many people who are trying to help asset owners reduce their risk and increase their viability and reduce safety problems and all kinds of other things. So there is a huge movement and there are a lot of players involved. And if you have any questions about what it might take in some of these areas that have nothing to do with Blastwave, feel free to reach out to me at tom@blastwave.com. This is the sword I'm going to die on. This is the mission I'm going to spend the rest of my life trying to solve. And I am here for you.
And I definitely want to thank Aaron for participating. This is it's very enlightening to kind of see the essentially at the end of the day, Aaron acts as an adversary. He's a friendly adversary, a white hat, not a black hat. But that perspective I think is really important for the OT owners or asset owners to hear. So thanks for attending. Thanks to Tom. Thanks to Aaron. And if anyone has any further questions, feel free to reach out to us, and we will. If you want to talk to Aaron, let me know, and we'll connect you up, and we'll get you connected, and he can help you out in your work as well. So thanks everyone for your time.
Thank you. Stay safe.
Thank you.